Hello students, we have seen the definition of indefinite integration. Any chapter of calculus is incomplete without a set of formulas, and in this module we are going to revisit the formulas of indefinite integration which we have seen in standard 11th. For the formulas we require the help of definition, and that's the definition which we have studied in the earlier module, which says d by dx of g of x is equal to f of x, then integral f of x dx is equal to g of x. Now students, using this particular definition we are going to write down a list of 13 standard formulas. We have to recall all the functions which satisfies the first condition, that is d by dx of g of x is equal to f of x. Now the simplest of them which comes to my mind is d by dx of x is equal to 1. This is what I know from derivatives. D by dx of x is equal to 1. Now if I compare, or if I just see with the definition, I can say g of x is nothing but x in this case, and f of x is nothing but 1 in this case. So as per the definition, if I have to go about, I can say that integral 1 dx is equal to x plus c, and this is the very first formula which we have in the list. On the same lines, let us derive some more. D by dx of x raised to n plus 1 upon n plus 1. Now you may wonder what is the answer, or you may not know it spontaneously. Let us do some rough work. D by dx of x raised to n plus 1 upon n plus 1 is required. Can we say that n plus 1 is a constant? So n plus 1 will be outside, and we will differentiate x raised to n plus 1. So we have 1 upon n plus 1 d by dx of x raised to n plus 1. On differentiating x raised to n plus 1, can I say we have n plus 1 x raised to n plus 1 minus 1. There is already a n plus 1 in the denominator outside, so this is what we will get. Now you can check here, n plus 1 will get cancelled, and also the plus 1 and minus 1 will get cancelled. So effectively, what is the derivative of the function? It's only x raised to n. So can I write here is equal to x raised to n? Is that clear? So as per the definition, what we will get? We will get integral x raised to n dx is equal to x raised to n plus 1 upon n plus 1 plus c, provided n is not equal to minus 1. Now you very clearly understand why n should not be equal to minus 1. Correct. If n is minus 1, denominator will become 0. The right hand side will become meaningless. So that condition is important. So what if n is equal to minus 1? And that's what we will discuss in the next formula. D by dx of log of mod x is equal to 1 by x is known to us. So if I were to apply the definition, we can say integral 1 by x dx is equal to log mod of x plus c. In this case, if you check, 1 upon x means x raised to minus 1. That is what we have as a formula here now. Now we have seen some algebraic functions, one logarithmic function. Now we will go for exponential function. Exponential, the very first thing that comes to your mind is d by dx of e raised to x, and everybody knows this formula. It is equal to e raised to x. So we can say integral e raised to x dx is equal to e raised to x plus c. So students, this is one formula which does not change in both the chapters, derivatives and indefinite integration. We have one more exponential formula, that is d by dx of a raised to x upon log a. Can I say it is only a raised to x? Very well. So what does the definition give us? It says that in this case g of x is a raised to x upon log a. So f of x is a raised to x. So as per the definition, we will have integral a raised to x dx is equal to a raised to x upon log a plus c. Is that fine? Now let us see some trigonometric formulas. We have d by dx of minus cos x is equal to what? It is equal to sin x. So what we can say is integral sin x dx is minus cos x plus c. Now this is one formula which many get confused. When they start recalling the formula, they get confused whether integral sin is plus cos or it is minus cos, because derivative of sin is plus cos. So students, remember, in derivative sin x will give you answer as cos x. In integration, sin x gives answer as minus cos x. Okay. Now next we will have is d by dx of sin x. The answer is cos x. So we can say integral cos x dx is sin x plus c. Is that fine? Let us take one more. What we have is d by dx of tan x. What is d by dx of tan x, students? It is sec square x. So we can say integral sec square x dx is equal to tan x plus c. Now let us see some more. What we have here is d by dx of minus cot x. What is d by dx of minus cot x? Cosec square x. So what is g of x in this case? It is equal to minus cot. What is f of x? It is cosec square. So what does the definition say? It says that integral cosec square x dx is minus cot x plus c. Now what next? Some more trigonometric terms, some more trigonometric formulas. d by dx of sec x is sec x tan x. So can we say integral sec x tan x is sec x plus c? Is that okay? Now 3 more to go. Let's see the next set of formulas then, the last 3. So what we have here is d by dx of minus cosec x. Can we say it is equal to cosec x cot x? So students, what is g of x here? It is minus cosec x and f of x is cosec x cot x. So can we say integral cosec x cot x is minus cosec x plus c? Likewise, can we say d by dx of tan inverse x is 1 upon 1 plus x square? So as per the definition, can I say integral 1 upon 1 plus x square dx is tan inverse x plus c? Last in the list, d by dx of sine inverse x, which is equal to 1 upon root of 1 minus x square. So can we say integral 1 upon root of 1 minus x square dx is sine inverse x plus c? So this is the list of 13 formulas which we will require in this chapter to begin with. The remaining formulas, as and when required, we will derive. That's all in this module. Thank you very much.